Hey there, science fans! Today, we're diving into the exciting world of robotics. You know, robots are becoming more and more common in our lives, from factories to hospitals. But have you ever wondered how robots navigate and interact with their surroundings? The answer lies in mechanical sensors, the senses that allow robots to perceive the world around them. Just like humans rely on our senses to understand our environment, robots depend on sensors to gather information. These sensors convert physical stimuli like touch or motion into electrical signals that the robot's brain, the controller, can understand. It's like translating the language of the physical world into a language that robots can comprehend. These sensors are crucial for robots to perform tasks accurately and safely. They allow robots to avoid obstacles, handle objects with precision, and even respond to changes in their environment. Think about a robot arm assembling a car. It needs to know how much force to apply to tighten a bolt without damaging the parts. That's where sensors come in. In the following sections, we'll explore some of the most important mechanical sensors used in robotics and see how they mimic human senses to give robots incredible abilities. Get ready to have your circuits blown away. One of the most important aspects of human interaction with the world is our sense of touch. We use it to determine the shape, texture and temperature of objects. In robotics, tactile sensors and force-torque sensors provide this crucial sense of touch. Force and torque sensors are like the stress balls of the robot world. They measure the forces and torques, twisting forces, acting on a robot's arm or gripper. This information is essential for tasks that require precise control of force, like gripping delicate objects or assembling intricate parts. Imagine a robot surgeon using a scalpel. It needs to apply just the right amount of force to make precise incisions without causing any damage. These sensors are also used in robotic systems that interact with humans, such as collaborative robots or cobots. Cobots work alongside human workers and need to be able to sense and respond to human touch to ensure safety. For example, if a cobot bumps into a human, force-torque sensors can detect the collision and trigger the robot to stop moving immediately, preventing any potential injuries. Force-torque sensors are like the robot's sense of touch, allowing them to interact with their environment with care and precision. In the next section, we'll explore tactile sensors, which provide even more detailed information about an object's surface properties. Stay tuned. Tactile sensors are like the fingertips of robots, providing them with a sense of touch that's even more sophisticated than force-torque sensors. These sensors can detect a wide range of properties, including pressure, temperature, and even texture. Some advanced tactile sensors can even differentiate between materials based on their thermal conductivity, which is how well they conduct heat. Imagine a robot picking strawberries. It needs to be gentle enough not to crush the fruit, but firm enough to pull it off the stem. Tactile sensors can help the robot determine the ripeness of the strawberry by sensing its softness and adjust its grip accordingly. No more squished strawberries. Tactile sensors are also being used to develop prosthetic limbs that can provide amputees with a sense of touch. These sensors can detect pressure and texture information from the prosthetic hand and transmit it to the user's brain, allowing them to feel objects again. This technology has the potential to significantly improve the quality of life for amputees, enabling them to perform everyday tasks with greater ease and dexterity. The development of more advanced and affordable tactile sensors is a key area of research in robotics. As these sensors become more sophisticated, robots will be able to perform an even wider range of tasks that require fine manipulation and dexterity. Section 4. Measuring motion with accelerometers and gyroscopes. Now let's talk about motion. Humans have an incredible sense of balance and coordination. We can walk, run, and even dance without falling over thanks to our inner ear, which contains sensors that detect motion and orientation. Similarly, robots rely on accelerometers and gyroscopes to measure their own motion and maintain balance. Accelerometers measure linear acceleration, which is the rate of change of velocity. They're used in everything from smartphones to cars to detect sudden movements or changes in orientation. In robotics, accelerometers are crucial for tasks like navigation, collision detection, and even gesture recognition. For example, a robot vacuum cleaner uses accelerometers to detect when it bumps into an obstacle so it can change direction. Gyroscopes, on the other hand, measure angular velocity, which is the rate of rotation around an axis. They're used to determine the robot's orientation and maintain balance. Think about a self-balancing robot or a drone. They use gyroscopes to stay upright and stable, even when subjected to external forces like wind or uneven terrain. By combining data from accelerometers and gyroscopes, robots can have a very accurate understanding of their motion and position. This is crucial for tasks that require precise movements like surgery or manufacturing. It's all about keeping those robots steady. Section 5. Contact sensors, knowing when and where to touch. Imagine you're reaching for a glass of water. You don't need to see your hand to know when you've made contact with the glass. That's because of the thousands of touch receptors in your skin. Similarly, robots use contact sensors to detect when they've made contact with an object or surface. Contact sensors are simple but essential sensors that provide a binary output, on or off. They're typically used to detect the presence or absence of an object, like a button being pressed or a door being opened. These sensors are often used as safety mechanisms too. For example, a robot arm might have contact sensors along its length to detect if it collides with an obstacle, triggering an emergency stop to prevent damage or injury. One common type of contact sensor is a limit switch. Limit switches are often positioned at the extremes of a robot's range of motion. This way, the robot knows when it's reached the limit of its movement in a particular direction. Although simple in design, contact sensors play a vital role in robotics by providing essential information about contact events, ensuring safe and reliable operation in various applications. Think of them as the on-off switches of the robot world.